Yellow, yellow, hello everybody. Oh, oh, okay. Hello, hello everybody. Okay, this is not the best audio setting. Hello everyone. Hopefully you guys are doing well. Um, so sorry, I'm coming after like so long, I think like 4 or 5 days. I've been traveling for some personal reasons. Couple of things are going on in life, so apologies regarding that. But I promise you, after 27th April, which is in 2 weeks, everything will be back normal, like our regular schedule. We'll be doing stuff. But I thought before I go back, because I don't have access to my personal desktop, I'll start working on something interesting. And as you can see from the title itself, I'm working towards something called AI influencer, right? In which I will be learning and teaching everyone here like how the AI works, some interesting stuff about neural networks, artificial neural networks, all those stuff because I've been learning. But and I will be providing some free resources that will help you create those things, which I'm trying to do. And I know like viewership will be very less for this one, but yeah, that's all I have. I wanted to be like still in contact with everyone, and yeah, so we'll be doing day one of our AI influencer project because that's how many days are left. Since you will see me in the proper space and a lot of things are different. So once you see my screen, I'm using a Mac right now. So that's also a very interesting thing. With that being said, yeah, now let's go for a transition. Just put it like this. So hopefully you guys can see me, you can hear me. Give me a thumbs up if you can. And let's get started with our AI project. We are going towards basically I'll show you from the start. What we are doing is going to Hugging Face. Hugging Face learn, right? And on the Hugging Face, there's agent course and a bunch of other things. What we are going to just focus 100% of our time on will be the Hugging Face diffusion model course, right? Because diffusion models are the one that helps from like text to media, like specifically images. And that's what we are working towards. We'll do the sign up. Wait, I should be logging in directly. Okay, one sec. I'll just share back my camera. Okay, because I added like Hugging Face on this. I don't know why it threw me out. And sorry if you guys are seeing like an ad right now. Let me go to. I'm just adding my Hugging Face ID so the progress is there. We can note, right? And we can use that. Okay, now I can share. So this is my ID, right? It's connected to Discord, so that's why you're seeing the Discord image. And let's work towards this. Here, let's go to learn our diffusion model course. I completed like Python. So Python, I some feel there are a lot of good stuff on YouTube you can learn Python from. I want to focus during the stream is first about deep learning, right? With PyTorch. PyTorch is framework by Facebook, right? And so well done. Even I don't know if you know, NVIDIA actually has like certain libraries with PyTorch that only works on their GPUs. That's how they're able to grab such a big AI market. They have created so many software or helped fund so many software that only works on their system. So PyTorch will work on just there's like not exactly all the PyTorch, but certain libraries. We don't have to worry right now about this because if you can see, right, I'm using a Mac here. So with this, you can basically use any of the Unix related or even on your computer or just spin up a machine on cloud, right? Completed Python, but you guys can, so I won't say Udacity, this one. Go on Free Code Camp. This one I heard is good, so we'll be going over this. Here's the course. Intro to Deep Learning by PyTorch. Let's learn and let's create our AI influencer model. The one I'm going for is something called Fit Tana. This one, right? The virtual soul, whatever. This lady, if you see, has 360,000 followers. Interesting if you read what it says. First AI influencer created in Spain. So basically, and with Clueless AI, this lady doesn't even exist. But here, Amazon, News, Egypt, New York City. And she's so real that a lot of people have messaged her thinking she's the real model. Even like some of the famous football players or singers. So that's like something, some like persona wise, that's how like realistic I want to make. Now let's go over this. Welcome to the course. Hi, I'm Lewis. Welcome. Hi, welcome everyone. Welcome to the course. Let me make this go back. Welcome to this course on deep learning with PyTorch. I censored. Don't give me this. So let's go here. I'm Louis, the lead instructor for this course. I've been in Udacity for nearly 3 years, teaching various machine learning, deep learning, and AI topics. Before Udacity, I was a machine learning engineer at Google, okay. And before that, I received a PhD in mathematics from University of Michigan, postdoc from fellowship in University of Quebec and at Montreal. Okay, beautiful. Huh. So basically, he's a big guy. From maths to AI and stuff, that's kind of what a lot of people like to go towards. Just want to make sure there's nothing, no messages, right? No messages from both sides, but I will drop the link so it's easy. Oh, one thing I can do is I'm on Mac. This will make life easy. Okay, we built this course as a blah blah blah. In this course, we'll be covering the concepts behind deep learning and how to build deep learning models with using PyTorch. We have included a lots of hands-on exercises, so by the end of the course, you will be defining and training your own state-of-the-art deep learning model. PyTorch, right? And it should be like the Python library one, pytorch.org. So PyTorch original. This will be nice, like they have Oro 2.6 is out, membership available. Interesting. So install PyTorch. Stable is 2.6, right? For Mac. CUDA. CUDA is the one I was mentioning, one of the softwares by NVIDIA, which only works on this system. Windows CUDA, right? So CUDA 12, this, interesting. We don't care about this because we will be going with the pip, Python, which are basics, right? Everybody love. Not be touching Java for this, and Mac, just for this, right? PyTorch is an open source Python framework with the Facebook AI research team used for developing deep neural networks. I like to think of PyTorch as an extension of NumPy that has some convenience classes for developing neural networks, accelerated computation using GPUs. And good part is in my other home computer, I have GPU, so it will be nice to play with it. PyTorch is designed with a Python first philosophy. It follows Python conventions, idioms, and works perfectly alongside popular Python packages like NumPy. PyTorch community and Facebook developers community. Our friends at Facebook have collaborated with us to bringing access to this free course and develop your skills in deep learning using PyTorch. Make sure you register to stay up to date with the latest PyTorch news, product updates, meetups, and programs like Developer Circles. Okay, this is interesting. Developer Circle is a good one because then you can use it. Okay, so PyTorch Developer Circle, Circle, or Developers Circle. No, what will be a PyTorch community? Should be somewhere here then. Become a member. Basically, it should be that then. Apply for membership today. Oh, it's part of Linux Foundation now. Okay, sounds good. Let's go next. Instructors. Hello, I'm Matt. Matt Leonard. Matt is the product lead for Udacity School of AI and a former content developer as well. Okay. Received his PhD in physics from University of Berkeley, where he spent most of his time as an exceptional experimental neuroscientist. During that time, he gained the love for Python, machine learning, neural networks, Bayesian statistics. I think I want to quickly have a look at this one. I've heard about this, I searched about this, I forgot what this is. Bayesian statistics is a statistical approach that uses Bayesian's theorem to update prior beliefs about parameters or hypotheses with observed data, resulting in posterior beliefs. It's characteristic of interpreting probabilities, blah, blah, blah. Theory provides a mathematical framework for updating probabilities based on new evidence. It's essential to allow us calculate probability. Okay, I don't know what this means. So let's see what this will say. Oh, this one. Probability A over B is probability of B over A, probability of A, and probability of D. That's why I was like, I've heard this. To me. Okay, let's see what Reddit did. Can someone explain to me this analysis to me like I'm five? I heard about a ton about in Carol's post, also Sam Harris podcast. Hey, I look it up. This appears to be a formal mathematical way to think about it, and another loser idea of what it means to be a good Bayesian. So that's not helpful. Also, at times, it seems like commentators of these podcasts are using term Bayesian differently. I seem to think implies different. And in case, long since common term. Okay. Okay, let's see which one has most. Top. This is the guy. So this is our big guy here, right? There's a bit of difference between merely knowing Bayes' lose rule and being a good Bayesian. I talk a bit about Bayesian as in the big picture, and this guy does a good job explaining it in another comment. To me, being a good Bayesian usually comes down to two things. First, understanding that we all have credences of all type of propositions that we would update those credences when new information comes in. So basically, we all have certain probability or kind of biases of all kinds of propositions, and that's not really an optional procedure. Okay. Appreciating the way in which new info really does update our outcomes. In particular, that is not enough to simply come up with a way that the new info can possibly be accommodated to by our favorite theory. It's less likely under theory A and then theory B. outcome in A could decrease relative to that in B. I have so confused. Okay, let's ask ChatGPT. Why is I like going 10 years old, not 5 all the time. Just some things are like better as 10, not 5. Alright, imagine you're a detective trying to solve mystery. Let's say it did it rain last night, but you didn't see it rain, and you are trying to figure it out based on clues. Bayesian statistics is likely to be like a super smart detective that uses new clues to update what already believe. So, what you already believe, this is your prior. Let's say you live in a desert where it usually doesn't rain. So before you even look outside, you think it's probably didn't rain. This is your belief. What you believe before seeing any clues. So I think step one, step zero. You find a clue. This is your evidence. You look outside and see ground is wet. Interesting. Now you think, well, it is wet. Maybe it rained, but you also know sometimes people water the garden and maybe a dog knocked over a bucket. So clue, wet ground could mean rain, but not for sure. So like moved probability. Update your belief. This is posterior. One sec. Now your brain says, okay, I thought it probably didn't rain, but now I see the ground is wet. That makes it a bit more sure it rained. That's Bayes' theorem in action. You start with one belief, then you use new evidence and update the belief. A bit of math, but friendly. Theorem looks like this. New belief is equal to how likely the clue, uh, if it is rained, if if it rained, how much you believe it could rain, how likely the clue is overall. Think how good the clue is, how much you already believe in it. So clue is a good amount of land is wet. Just one bucket wouldn't do it. Maybe the gardener did. So it's a good clue. I believe they do once a week, so maybe. And then how surprising the clue. That's pretty surprising. They did it twice. Real life example for fun. Imagine you think your father might sneak a cookie from the jar, like he usually does. Before looking, you believe that 70% chance he did. Then you see cookie crumbs on the table. Aha, that makes me more sure he did. Every new clue updates your thinking. Okay, I got the idea, basically. I did SAD, Matt also built courses on Hadoop, data visualization, Python tools like Conda and Jupyter, and deep learning. Cool. In this course, Matt will be teaching you basics of PyTorch and how to use new features for deploying models. Interesting. Cesane Camacho. Cesane is a computer vision and deep learning expert with master in electrical engineering from Stanford. As a former genomics and biological imaging researcher, she applied machine learning to field of medical diagnosis. You're mostly interested in how humans reason, how to use the logic to become a better teacher or programmer. She will teach you using PyTorch to define and train conventional. Okay, Alex, deep reinforcement learning nano degree program lead, right? She is an expert in machine learning, master's in computer science from Brown University, and master's in applied mathematics from Michigan. We'll be teaching you conventional neural networks, powerful architecture. Okay, so Neutral for now. I don't know much about this course, right? Neural networks. Okay.
So let's start with two questions. What is deep learning and what is it used for? The answer to the second question is pretty much everywhere. Recent applications include things such as beating humans in games such as Go or even Jeopardy, detecting spam in emails. Diffusion is pretty much everywhere. Recent applications include things such as beating humans in games such as Go or even Jeopardy, detecting spam in emails, forecasting stock prices, recognizing images in a picture, and even diagnosing illnesses, sometimes with more precision than doctors. And of course, one of the most celebrated applications of deep learning is in self driving cars. And what is at the heart of deep learning? This wonderful object called neural networks. Neural networks vaguely mimic the process of how the brain operates, with neurons that fire bits of information. It sounds pretty scary, right? As a matter of fact, the first time I heard of a neural network, this is the image that came to my head. Some scary robot with an artificial brain. But then I got to learn a bit more about neural networks, and I realized that they're actually a lot scarier than that. This is how a neural network looks. As a matter of fact, this one here is a deep neural network. It has lots of nodes, lots of edges, lots of layers, information coming through the nodes and leaving is quite complicated. But after looking at neural networks for a while, I realized that they're actually a lot simpler than that. When I think of a neural network, this is actually the image that comes to my mind. There's a child playing in the sand with some red and blue shells, and we ask the child, can you draw a line that separates the red and the blue shells? And the child draws this line. That's it. That's what a neural network does. Given some data in the form of blue and red points, the neural network will look for the best line that separates them. And if the data is a bit more complicated, like this one over here, then we'll need a more complicated algorithm. Here, a deep neural network will do the job and find a more complex boundary that separates the points. So with that image in mind, let's dive in and learn about neural networks.
I like that. Simple introduction using like some categorization and stuff. That's pretty cool. I like this one. So intro, classification problem. So what we'll do is classification problem one, two, maybe linear boundaries. How many are there? 2.50. Origins of PyTorch, debugging, designing PyTorch from research, production, blah blah blah. There's so much. Okay, we'll keep going. Classification problems one, right? Classification problems. We'll start by defining what we mean by classification problems and applying it to a simple example. Okay, let's see.
So let's start with one classification example. Let's say we're the admissions office at a university and our job is to accept or reject students. So in order to evaluate students, we have two pieces of information, the results of a test and their grades in school. So let's take a look at some sample students. We'll start with student 1 who got 9 out of 10 in the test and 8 out of 10 in the grades. That student did quite well and got accepted. Then we have student 2 who got 3 out of 10 in the test and 4 out of 10 in the grades, and that student got rejected. And now we have a new student 3 who got 7 out of 10 in the test and 6 out of 10 in the grades, and we're wondering if the student gets accepted or not. So our first way to find this out is to plot students in a graph with the horizontal axis corresponding to the score in the test and the vertical axis corresponding to the grades. And the students would fit here. The students who got 3 and 4 gets located in the point with coordinates 3, 4. And the student who got
Mm-hmm.
9 and 8 gets located in the point with coordinates 9, 8. And now we'll do what we do in most of our algorithms, which is to look at the previous data. This is how the previous data looks. These are all the previous students that got accepted or rejected. The blue points correspond to students that got accepted, and the red points to students that got rejected. So we can see in this diagram that the students who did well in the test and grades are more likely to get accepted, and the students who did poorly in both are more likely to get rejected. So let's start with a quiz. The quiz says, does the student 3 get accepted or rejected? What do you think? Enter your answer below. So let's start with one classification example. Enter.
So wait, we are looking at 7 and 6. So if I remove this, 7, 6. He got accepted, basically, right?
Your answer below.
Student 3, does the student accepted or rejected? Yes. Thank you for completing. Certainly, the student is represented by the point coordinate 7, 6, and that is point falls in the positive area of the model, basically the blue area. That works. Oh, next, what is downloads? Video zip file transcript? No, I don't need that. Excuse me. Now let's go for this one.
Correct? Well, it seems that this data can be nicely separated by a line, which is this line over here. And it seems that most students over the line get accepted, and most students under the line get rejected. So this line is going to be our model.
Mm-hmm.
The model makes a couple of mistakes since there are a few blue points that are under the line and a few red points over the line, but we're not going to care about those. I will say that it's safe to predict that if a point is over the line, the student gets accepted, and if it's under the line, then the student gets rejected.
Yeah.
So based on this model, we look at the new student and we see that they're over here at the 0.76, which is above the line. So we can assume with some confidence that the student gets accepted. So if you answered yes, that's the correct answer. And now a question arises. The question is, how do we find this line? So we can kind of eyeball it, but the computer can't. We'll dedicate the rest of this section to show you algorithms that will find this line, not only for this example, but for much more general and complicated cases.
Nice. Okay. Video zip file, transcript zip file. No. Okay, lesson wise. Given the table in the video below, video above, what would the dimension be of the input feature X, the weight OW, and the bias V to satisfy WX plus V? Oh wait, I did a couple of these. My bad. Huh. I accidentally did a couple of those. My bad, lads. Acceptance at a university. Boundary line. Okay.
So first let's add some math. We're going to label the horizontal axis corresponding to the test by the variable x1 and the vertical axis corresponding to the grades by the variable x2. So this boundary line that separates the blue and the red points is going to have a linear equation. The one
Mm-hmm.
drawn has equation 2x1 plus x2 minus 18 equals 0. What does this mean? This means that our method
Twice. Like basically this means the test weightage of test is twice as much as the grades, and then to find it should be equal to 18 or more than that.
for accepting or rejecting equals 0. What does this mean? This means that our method for accepting or rejecting students simply says the following. Take this equation as our score. The score is 2 times test plus grades minus 18. And when the student comes in, we check their score. If their score is a positive number, then we accept the student. And if the score is a negative number, then we reject the student.
So basically 2x plus 2x1 plus x2 is greater than 18, or 2x1 plus x2 minus 18 is greater than 0.
This is called a prediction. We can say by convention that if the score is 0, we'll accept the student, although this won't matter much at the end. And that's it. That linear equation is our model. In the more general case, our boundary will be an equation of the form w1x1 plus w2x2 plus b equals 0. We'll abbreviate this equation in vector notation as wx plus b equals 0, where w is the vector w1, w2, and x is the vector x1, x2. And we simply take the product of the two vectors. We'll refer to x as the input, to w as the weights, and to b as the bias. Now for student coordinates x1, x2, we'll denote the label as y, and the label is what we're trying to predict. So if the student gets accepted,
Wait,
and the
hold on.
label is now for student coordinates x1, x2, we'll denote the label as y, and the label is what we're trying to predict. So if the student gets accepted, namely the point is blue, then the label is y equals 1. And if the student gets rejected, namely if the point is red, then the label is y equals 0. Thus, each point is in the form x1, x2, y, where y is 1 for the blue points and 0 for the red points. And finally, our prediction is going to be called y hat, and it will be what the algorithm predicts that the label will be. In this case, y hat is 1 if the algorithm predicts that the student gets accepted, which means the point lies over the line, and
Mhm.
y hat is 0 if the algorithm predicts that the student gets rejected, which means the point is under the line. In math terms, this means that the prediction y hat is 1 if wx plus b is greater than or equal to 0, and 0 if wx plus b is less than 0. So to 0,
Yeah.
prediction y hat is 1 if wx plus b is greater than or equal to 0, and 0 if wx plus b is less than 0.
Mhm.
So to summarize, the points above the line have y hat equals 1,
So this is more like a if-else statement. If WX plus B greater than 0, print 1, else print 0, right?
and the points below the line have y hat equals 0. And the blue points have y equals 1, and the red points have y equals 0. And the goal of the algorithm is to have y hat resembling y as closely as possible, which is exactly equivalent to finding the resembling y have y equals 0. And the goal of the algorithm is to have y hat resembling y as closely as possible, which is exactly equivalent to finding the boundary line that keeps most of the blue points above it and most of the red points below it.
Hmm. That last line
It's
isn't.
exactly equivalent to finding the boundary line that keeps most of the blue closely as possible. And the goal of the algorithm is to have y hat resembling y as closely as possible, which is exactly equivalent to finding the boundary line that keeps most of the blue points above.
So basically, WX plus B is the line we wanted to find, and Y is the answer we're looking. Now that you know that 2x1 plus 2 plus x2 minus 18 is equal to 0, and similarly the score, this one, what is the score of the student who got 7 in test and 6 in grade? 7 in test. Test was at the x1, right? So 2 times 7, 14, right? So it will be 2 times 7 plus 6 minus 18. So this becomes 14 plus 16, which becomes 20. And because it becomes true, but answer, which basically means it is greater than 0. And it should be one. What is the score of the student? Score will be 2 because it's asking for score. But it was, if it was like given in that y hat format, it would be 1, right? Cool. That's nice. Higher dimension. Okay. This is probably the last one we'll do because I think this one is very similar, but you just have to think it in a, instead of a linear, you have to think, let's say, imagine a corner of the house, right? And from there is three dimension up, one side, other side, right? And that's what we are going to do with this one, and we'll see what
Now
perceptrons
you may
is.
be wondering what happens if we have more data columns, so not just tests and grades, but maybe something else like the ranking of the student in the class. How do we fit 3 columns of data? Well, the only difference is that now we won't be working in 2 dimensions, we'll be working in 3. So now we have 3 axes, x1 for the test, x2 for the grades, and x3 for the class ranking. And our data will look like this, like a bunch of blue and red points flying around in 3D. And our equation won't be a line in 2 dimensions, but a plane in 3 dimensions, with a similar equation as before. Now the equation will
So this is basically, let's say if I'm holding my phone, right? All the points above blue, all the points below is this. And this is like kind of cutting like a plane, this whole area.
be w1x1 plus w2x2 plus w3x3 plus b equals 0, which will separate the space into 2 regions. This equation can still be abbreviated by wx plus b equals 0, except our vectors will now have 3 entries instead
Abbreviated.
of 2. And our prediction will still be y hat equals 1 if wx plus b is greater than or equal to 0, and 0 if wx plus b is less than 0. And what if we have many columns, like say n of them? Well, it's the
Multi-dimensional.
same thing. Now our data just lives in n-dimensional space. Now, I have trouble picturing things in more than 3 dimensions, but if we can imagine that the points are just things with n coordinates called x1, x2, x3, all the way
Hard
up
to
to
create
xn,
something like that.
with our labels being y, then our boundary is just an n minus 1 dimensional hyperplane.
So in linear, basically two-dimensional, right? There are two linear, one dimension, like linear, right? L.
Which is the high dimensional equivalent of a
And boundary was a line. Line is one-dimensional, straight. The plane was linear, two-dimensional. The thing that we are looking for that divides accepted and non-accepted is minus one of the total dimension.
minus 1
Like plane in the second one was a two-dimension. It was a plane. It was inside a three-dimensional.
with our labels being y,
Like imagine like a paper sheet in your house if you just throw it anywhere, like basically holding in air, right?
then our boundary is just an n minus 1 dimensional hyperplane, which is the high dimensional equivalent of a line in 2D or a plane in 3D. And the equation of this n minus 1 dimensional hyperplane is going to be w1x1 plus w2x2 plus all the way to wnxn plus b equals 0, which we can still abbreviate to wx plus b equals 0, where our vectors now have n entries. And our prediction is still the same as before. It is y hat equals 1 if wx plus b is
Accepted or not.
greater than or equal to 0, and y hat equals 0 if wx plus b is less than 0.
Nice. So let's finish this and go to bed. Given the table in the video above, what would be the dimensions be? What would the dimensions be for input features x and weight w and bias b to satisfy this? So basically, what would be um, dimension b for the input feature x and weight w? So b is 1 by, so it is w is weights. There will be total weights. And so how many weights will be there? There will be n weights, right? Because and same will be the case for total x, right? Total total dimensions for w is x. Same with w. The total dimensions for w are n. Same with x, but b will be 1. So it should be the dimensions. These b should be 1. So one of these. And here it is. They both should be in the same. Oh no, wait. It should be like the matrix, right? So this should be more like when we create like this is more like about matrix multiplication. So this is kind of a matrix with like n rows and one column. And this one, oh, I should this one. This one is one row and n columns. And how they multiply? Let's say this is one, two, three, four, n. Right there, dot dot. There are dots. One, two, three, four, and dot dot stuff like that. So one, two multiplies with two. So that's how we are doing. And it becomes like a n by n, but we want like a one by one. Is it will have n. and n. One will multiply with all these, and two will multiply with all these, right? What we want is, and because the middle one, let's say if it is n times 1 matrix multiplies with 1 times n, the middle one should be same. These, it could be m, let's say here. These should be same, the middle one. So what we want is like wx, right? Which is like a 1 answer. So we want is 1 times, what we want is 1 times n matrix and s1 and n times 1 matrix. So it becomes 1. This is a 1 by 1, right? Just a simple answer. So that's our answer, 1 by n and n by 1. 1 times n and n times 1. And with b is 1. That's our answer. Correct, right? See? Hopefully you understood. This is like matrix multiplication. It's a mathematical thing. You probably learned it in like high school. I don't know. In Canada or North America, I know about India. We did. Perceptrons, let's see this tomorrow. What we'll do tomorrow is perceptrons, why neural network, perceptrons and logic operators. Tomorrow will be perceptrons day. Log loss, error, function, discrete, software, one hot encoding, cross entropy. This is all mathematical, so mathematical. I don't know how much we'll cover, hopefully some, because then the faster we cover this tomorrow, it'll be easy to move to third. We're talking PyTorch with Sumit Chintala, right? And then PyTorch will be implementing stuff which I really want. Loading images data. Okay, cool. One thing I want to learn is like, does courses courses are in how say stable diffusion course. Okay. So basically this will give us like PyTorch idea. And once we go to let's go to Hugging Face again. Introduction to diffusion, fine-tuning, stable diffusion, right? Diffuser libraries, diffusion models from scratch, fine-tuning diffusion models, right? Create your own custom diffusion model pipeline. Pipeline is an interesting thing to create, though. I'll give them that. And fine-tuning, stable diffusion. This is where for after fine-tuning, this will come. Going further with diffusion models, TDMI, diffusion for audio. Okay, okay, beautiful. So we will have some stable diffusion. This won't go waste. Okay, okay, that's good to know. Sweet. So thank you everyone so much for watching. Tomorrow we'll go for at least 2 hours of learning. Today was just 45 minutes starting day one. Need to define, need to get just started. So tomorrow will be big and long weekend coming. Stay tuned. Thank you so much though. Have a good one. I'll see you tomorrow. Bye. Go like this. Bye.